In this video, we will discuss combinations. When we discuss permutations, the order of the object is important. When we choose president, secretary, and treasurer for our club, it matters whether Evelyn is president, Bill is secretary, and David is treasurer, or Bill is president, David is secretary, and Evelyn is treasurer, even though the same people are involved. However, if we select 3 members to serve on a committee, it doesn't make any difference in what order they are chosen. Bill, David, Evelyn, or Evelyn, Bill, David, the committee is the same. When order doesn't matter, we are picking combinations. There are n things available and we are choosing n of them. So we write n choose r, NCR, and read n choose r. The factorial formula for combinations, the number of combinations of n distinct things taken r at a time, where r is less than n, can be calculated by n choose r is equal to n pick r divided by r factorial, or n factorial divided by r factorial times n minus r factorial. Let's evaluate some combinations. 9 choose 7 is 9 factorial divided by 7 factorial times 9 choose 7, 9 minus 7 factorial. That's 9 times 8 times 7 factorial over 7 factorial times 2 factorial. Those 7 factorials cancel. We're left with 9 times 8 over 2, which is 9 times 4, which is 36. Or we might have 24 choose 18 factorial. That's 24 factorial over 18 factorial times 6 factorial. And we do a lot of canceling and multiplying, and you'll want to use your calculator for this. And we get 134,596. We can also just go into Google and tell Google what we're looking for. If I click on, let's see, let's share, share screen, there it is. So here is what I'm going to share, just going into Google here. And I'm just telling Google to do 24 choose 18. And we'll get that same number, 134,596, exactly the same number. You can tell Google to do this stuff rather than carrying it out by hand, by and large. Your calculator may also have ways of doing this. If you have a scientific calculator, it probably does. But if you can't figure out how to do it on your calculator, just go into Google and ask Google to do it for you. Observe that n choose 0 is equal to n factorial over 0 factorial times n minus 0 factorial, which is n factorial over 1 times n factorial, which is just 1. And n choose 1 is n factorial over 1 factorial times n minus 1 factorial, which is n times n minus 1 factorial over n minus 1 factorial, which is just n. So these numbers are the same as the permutations. So we have n choose 0 equals n pick 0 equals 1, and n choose 1 equals n pick 1 equals n. We'll do one more example. A common poker hand consists of 5 cards dealt from a standard deck of 52 cards. How many different 5-card hands are possible? The order of the cards is not important since the hand depends on the cards in hand, not the order in which they are dealt. We use combinations and likely a calculator or Google. So 52 choose 5 is 52 factorial over 5 factorial times 52 minus 5 factorial, which is 52 factorial over 5 factorial times 47 factorial, and we get 2,598,960 different hands out of a 52 card deck.